Hey guys, this is Tuesday's math work. Today we're going to continue doing like we did yesterday with the reviews and stuff. So, Tuesday. Okay, some of these questions may sound familiar to your assignment, your practice. I just had a blank. Your assignment that you're supposed to do last night by yourself. That's because this was used. It's what I used last year. We don't have this program anymore, but I really loved it. And I would just create worksheets, and I may have used the same question multiple times, but that's okay. The more practice, the better we can be. Okay, so this is where we're going to start off today. Now, I do have, where to go? I'm just going to use the same one, my place value chart from yesterday. Okay, which number does the 6 have a value that is 10 times the value in 456 and 3/10? So 456 and 3/10. What is the value of the 6 first? That's what we got to find out. The value of the 6 in 456 and 3/10. The 6 is in the ones place, so the value is 6. All right, now let's see what the question says. It says, which number does the 6 have a value that is 10 times? So we have 6, 10 times is 60. So when we look through here, we have to find the number that has a 6 with a value of 60. Basically, we're looking for place value, guys. Okay, right here, the 6 is in the thousands place, which means it's worth 6,000. What place value is the 6 in right here? The hundreds, so it's 600. What place value is the 6 in here? It's in the tens place, so that would be 60. And the 6 right here is in the 1, so that makes it 6. So remember to read the question proper, because I can guarantee you about a quarter of you would have chosen D, because it's the same thing as this. But it's not asking you that. It's asking you to show the number that the 6 has a value that is 10 times this. And we know that 6 times 10 equals 60. So that's what we're looking for. That is what we are looking for. Now, let's go to the next one. Which statement is true about the number 6,438? Let's just go ahead and write this number down. 6,438. All right, so let's read it. I'm sorry, that tweaked a little. Okay, it says the 6 represents 600. Well, the 6 is in the thousands place, so that means it represents 6,000. So that's a no. The 4 represents 400. The 4 is in the hundreds place, so that means it is 400. But, remember, just going to put a dot there. The 3 represents 300. The 3 is in the tens place, so that represents 30, so that's a no-go. And the 8 is in the ones place, which makes it 8, not 800. So B is my answer. See, if we work these problems, if you just break them down to the smallest way you can answer these questions real easy. Okay, next question. Consider the numbers 68 and 49 hundredths and 6 and 849 thousandths. Which statements accurately reflects the relationship between the values of the 4 in each number? Accurately is another word for correctly. Okay, so we're going to write these. I'm going to go ahead and write these down on my chart. So I have 68 and 49 hundredths. Then I have 6 and 849 thousandths. Okay, it's like right there. So I'm going to use this to help me answer these questions. Okay, letter A says the 4 in 68 and 49 hundredths is smaller or has a smaller value than the 4 in 6 and 849 thousandths. So let's look at the value here. The 4 right here has a value of a tenth. So that means it is worth 4 tenths. The 4 in 6 and 849 thousandths is in the hundredths place. So that makes it have a value of 4 hundredths. So 4 tenths is that greater than, less than, or equal to 4 hundredths. Think of it this way. When you have 4 tenths, let's say you have this little stick and it's divided into 10. 3, 4, 5. I don't even know how many that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and you said 4 tenths. That means 4 of these are colored in. Now, if you say 4 hundredths, and I'm not going to do the whole thing, that means you have the cube. And there's 100 little units, and only 4 of them, 1, 2, 3, 4, are colored in. So which one is larger? This one. Because this is worth 4 tenths, and this is worth 4 hundredths. Remember, the further away from the decimal it is, the smaller it is. So this is false. Okay, the 4 in 68, I'm just going to say the number, 68.49 is larger than the value in the 4 in 6. That's right, because it's the opposite of what we just did. So, yes. All right, the value of the 4 in 68 and 49 hundredths is 10 times, I'm going to circle that or underline it, 10 times larger than the value of the 4 in 6 and 849 thousandths. Let's look. Okay, here it is in the tenth, here it is in the hundredth. How many places off is it? It's 1 place. And remember, each place represents 10. So this 4 is 10 times larger than the 4 in the hundredths place. So it is. Because you can line them up like this. And you can see if you move this decimal 1 place over, they're equal. So it is 10 times greater. Okay. Now, if you watched yesterday's video, which I know you did because y'all are great kids, you know that we have a base 10 system, which means you're either going to be 10 times greater, 100 times greater, 1,000 times greater, and so on. Or you're going to be 1/10 the value, 100th the value, or 1,000th the value. You're not going to be 40. You're not going to be 400. Okay? Let's go ahead and mark those off right now. Okay, the value of the 4 in 68 and 49 hundredths is 100 times greater than the value. Well, now we know that's false because we already answered that it's 10 times greater. So 2. All right, so the table shows each digit value of 99 and 999 thousandths. Which statement is true? Okay, this is where you have to do it. So I'm just going to write it over here. The V, so that'll be 90, is 1/10 the value of 9. 1/10, that means less. That means like 1 is 1/10 of 10. That's what that means. So is 90 1/10 of 9? No. 90 is 10 times the value of 9. So this one's wrong. I had a water somewhere. And it's back at my desk. Okay. X, which is 9/10, is 1/10 the value of W, which is 9. Okay, 1/10. So we have to figure out how many times I got to move that decimal to equal to 9. And how many times did I have to move it? 1 place. So that is true. So 9/10 is 1/10 of 9. Because if you multiply by 10, you get 9. So I'm going to put a dot right here. Y, which is 9/100, is 10 times larger than X. All right, well, that's wrong because this is smaller than that one. So it's not 10 times larger. It's 10 times smaller. Z, this is the same thing. No, it's actually 100 times less. So your answer is B. Okay, number 5. Which statement about the value of the 7 and the 5 are true? We did this one yesterday. Didn't we? I think we did this one yesterday. Going back to my notes. 1 second. Purple pen yesterday. Yes, we did. It was D. Just go ahead and write it down. We did this one yesterday. Okay, how many times greater is the value of the digit 5 in 73,680 and 59 hundredths as compared to the value of the 5 in 62,410 and excuse me, and 25 hundredths? So I'm just going to write down the values of the 5s. Okay, so I have 5/10 compared to 5 hundredths. Okay, so first things first, remember, the further away the number is from the decimal, the smaller it is. So out of these two numbers, this one is the larger. So when we go to compare the two, we have to say that this right here is 1/10 or 100th or 10 times or 100 times the value of this one. So that's how you say it. So if we look right here, the best way for me to tell you to figure this out is to move your decimal. First, which way do we have to move the decimal to make this number right here equal 5/10? We have to move it to the right. That being said, that means you are adding, which means the number is going to get bigger. So it's going to be a whole number. How many times did we move it? 1 time. So how many times greater is the 5 in the first number compared to the 5 in the second number? It's 10 times. Because let's say the question was reversed and it said how many times whatever value is this compared, that's the same number. How many times greater is the value of this compared to that? The thing is, when it says greater, you can actually use it as 1/10 the value. It's fine. So what you have to do is you have to find out how many places over you would have to move to have the numbers be the same. That's the best way I have figured it out. So to get the 5/10 equal to 5 hundredths, I have to move the decimal to the left, which means it's getting smaller, which means it's going to be a fraction. How many times? 1 time, so 1/10. That's the best way I've come up with figuring that one out. Okay, this was part of your homework yesterday. And when we are dividing a decimal like that, you're actually moving the decimal over I'm just, because this was part of your homework last night. Okay. So you have 2 and 6/10 divided by 1/10. So basically what you're doing is you're moving the decimal. It's really weird because in my mind it's the reverse of it, but when you move, like when you have this right here and you're dividing, you move the decimal to the right. Don't ask me. I don't even, like I said, to me it would be the opposite, but it's not. So I have to think back in my head. Don't do it that way. So when you're dividing a decimal like this, a base 10 decimal, you move the decimal this way. If you're multiplying, it's the opposite. Okay. So how many times do I have to move this decimal over? This is 1/10. So that means one place to the right. And that gives me a whole number of 26. Number 8. Alice bought a ticket for the movies that has the number 9,786 on it. What ticket does the 8 have 1/10 the value of the 8 in Alice's ticket? Okay, so let's look at this number, 9,786. What is the value of that 8? Well, it's 80. So we have to find out what 1/10 of 80 is. Now remember, I just talked about it. When we are dividing a fraction or a decimal, not dividing, we're multiplying, the decimal moves to the left. So we're looking for a number that has an 8. So 8, and it's in the ones place. A. Okay, 9. If 1 and 23,000th is multiplied by 10, where would the decimal in the number move? Okay, remember, when we are, now this is the opposite of decimals. When we are multiplying when we're multiplying whole numbers, base 10 numbers, the decimal always moves to the right. I know it's the opposite of decimals. Just bear with me, okay, guys? So, go that way. How many times we move it depends on how many zeros we got. 1 0. 1 time. So we're going to move the decimal 1 time to the right. So that's 1 place to the left. That's a no-go. Okay, this says right 1 place. That's a maybe. To the left 2 places. Nope. To the right 2 places. No. Okay, the 5-digit number is shown below. Okay, 5 digits. That's 6 digit. That not 6? That is 6. A 5-digit number is shown below. That's not right. Okay. I have 1,799 and 98 hundredths. Okay. So, and this is underlined. I'm going to go ahead and do the value of it, and that's the value of 9. Okay. And if you want to, you can always go right here. Okay. So, here's the things. This is worth 9. The underlined digit is 10 times greater than the digit to its left. Remember, left and right, guys. This is left, this is right. So that is saying that this 9 right here, the one that's underlined, is 10 times greater than this one. What's the value of this 9? It's in the tens place, so it's 90. 9 is 10 times greater than 90? I don't think so. Okay. The underlined digit, which is 9, is 1/10 of the digit to the right. So let's go right here. 9 is in the tenths place, so that equals 1/9. So 9 is 1/10? That means it's smaller than 9/10? No. Okay. The underlying digit is 10 times smaller than the digit to its right. Basically, that's a repeated number. That's basically saying letter B in a different way. So letter D says the underlying digit is 1/10 of the digit to its left. 90. So you would have 9 is 1/10 of that, which is correct, because if you were to multiply 9 times 0.1, you would move the decimal one place over to the left, and you get 9. So the answer is C. Nope, the answer is D. I'm sorry. Okay, that is number 10. Now, we have this one's only 5 questions. I have 7 minutes. I can do it. All right, now, this is part 2 of your lesson. How much larger is the value of the 3 and 903 and 7/10 than the value of the 3 and 4 and 31/100? So just like we did earlier, I'm going to write the values down. I have 3, and then I have a number with a value of 3/10. Okay. First off, what's my rule for a base 10 system here, people? It can only be 10, 100, thousands, or something like that. So we cannot have a 30, and we cannot have a 3. Because if you say that 3 is 3 times larger than 3/10, you're basically saying 3 times 3. That's not a base 10 number. Okay? All right. So, remember what we have to do. We have first to decide which direction this decimal right here needs to move so I can get it equal to 3. Well, we know it's going to move to the right. So that means that it's going to be a whole number. Okay? How many times did we have to move it? 1 place. And remember, each place we move has a value of 10. So your answer should be B. All right, Peyton has 73 $1 bills. She takes them to the bank to get them exchanged for $10 bills. If the bank gives Peyton as many $10 bills as possible, $10 bills, how many $1 bills does she have left over? All this is division. That's all it is. You are dividing 73 by 10. That's all you're doing. Okay? It's not that big of a trick. So, I have 10 as my divisor, 73 as my dividend. So, how many times will 10 go into 70? We should know that right off the bat, 7 times. Okay, so 7 times 10 is 70. Subtract, I have a remainder of 3. So that means Peyton is going to get 7 $10 bills. 7 $10 bills equals $70. But she gave the teller $73. So how many $1 bills is Peyton going to get back? The remainder. 3. $3 bills back. Because 73, she would get 7 10s, 3 1s. Unless the bank ran out of 1s, and then it'd be up a creek. Okay. So consider the number 54 and 162 thousandths and 5,416 and 2/10. Which statement accurately reflects the relationship between the sixes? Okay. So the first number, the 600ths, the second number is 6. Okay, the 6 and 54 and 162 is greater value than the 6 here. So they're saying that 600ths is greater than 6. No. The 6 in 54 and 162 thousandths is smaller than the value of the 6. Yes, because 600ths is smaller than 6. The value of the 6 in 5,416 and 2/10 is 10 times greater than the value of the 54 and 162 thousandths. Okay, remember to do that. We have to decide which direction first we have to move it to get equal the 6. Okay, we have to move the decimal this way. So that means it is going to be a whole number. How many times did we have to move it? 1, 2. And each one of these equals 10. 10 times 10 is 100. So it's actually 100 times greater. So that's wrong. And this one is saying the reverse of it. This one's saying this one's 10 times larger than this. And we already know that's false. The value of the 6 in 5,416 and 2/10 is 100 times greater than the value of 54 and 162 thousandths. We already know that's true because we did the work up here. And that means F is wrong. Okay. Okay, number 4 says Mike paid $3.50 for a painting he bought online. He sold the painting at a crafts show for $35. Which statement correctly compares the change in the painting's value? So Mike went on eBay or whatever. He bought it for $3.50. He sold it for $35. So what you're going to do is you're going to look and see how many places I have to move this decimal to equal 35. So first, which direction? I'm moving it to the right, so that means it's going to be a base 10 number. Base 10, guys. Remember, 30 is not a base 10 number. So that takes 2 out automatically. So I move it one place and I get 35. So I have Mike sold the painting for 10 times the price he bought it for. Or I have Mike bought the painting for 10 times the price he sold it. Mike only paid $3.50, but he sold it for $35. That means he made money. So Mike sold it for 10 times what he purchased it for. Okay, this one is the same way. This one we may actually have to write stuff down. Cameron read that his favorite NBA team won the game last night by a score of 142 to 124. That was a high-scoring game, which is true about the 2 in each number. Okay, so I have 142 compared to 124. All right, the 2 in the 142 has a value of 2. The 2 in 124 is in the tens place. That means it has a value of 20. So let's look at our options here. The 2 in 142 represents a greater value than the 2 in 124 because 142 is greater than 124. I may not know a lot, but I do know that 2 is less than 20. So that's not right. Okay, the 2 in 142 represents a greater value than the 2 because 124 is further to the right. That doesn't make any sense. That doesn't make any sense. Okay, the 2 in 142 represents 1/10 of the value of the 2 in 124. 1/10 means it's smaller. So I have a 2 and a 20. Here's your decimal. How many times do I have to move that decimal over to equal 20? 1 time. So that is 1/10. So let's look right here. You have the 2 in 142 represents 10 times the value of the 2. Nope. So it's C. All right, guys, that is it for your notes today. That's not bad, 30 minutes. So I'll be posting your practice and problem solving here in a second. Have a good afternoon.